Chapter 6.4 exercises 15 through 22. This section in the book, 6.4, has to do with polar coordinates. And we're going to do the odd number problems in this set: 15, 17, 19, and 21. And exercises 15 through 22 use an algebraic method to find the rectangular coordinates with given polar coordinates. Approximate the exact solution values with a calculator when appropriate. Well, what we're doing for polar coordinates, we're given a radius. This first value is an r and then an angle. So the format is going to be r, comma, angle. Okay, and then the formula we're going to be using to change from polar coordinates to rectangular coordinates are these. We have r cosine theta equals x, and r sine theta equals y. And the problem instructions mention appropriateness of exact solution values, and we're going to kind of go through that as we get through these problems here. In the first one, we have a radius of 1.5 and an angle of 7 pi over 3. Well, what we try to do is we try to get an angle between, an equivalent angle between 0 and 2 pi. Well, in this case, 7 pi over 3, if we made a mixed number of this, we would have 2 and 1/3 pi. So it'd be 2 pi plus pi over 3. And so this 2 pi represents an entire rotation. So we're rotating, if we draw a unit circle here, as I've done on the lower right, this pi over 2, this 2 pi is rotating around 2 pi, which is equivalent to 360 degrees, plus another pi over 3. So we're going to end up in the same place, or have the same terminal angle as an angle that has a measure of pi over 3, which is equivalent to 60 degrees. Okay? And so basically we're looking at the cosine and the sine. And so the cosine, along the unit circle anyway, is going to be 1/2. And the sine value, which is what this is raised, the elevation, is going to be square root of 3 over 2. And so what we have is that x equals r cosine theta, which in this case equals 1.5, which I'm going to change into fraction form of 3 over 2, and times 1/2. And multiplying 3/2 by 1/2, we get 3/4. So that's going to be our x value. Our y value is going to be, again, r sine theta, which in this case is going to be 3/2 times the sine, which is square root of 3 over 2. So in this case, we're going to get 3 square root of 3 over 2 times 2, which is 4. And I think the book puts it in the form of 3/4 pi square root of 3, which really between the two there's no difference. So this would be our rectangular coordinates. Okay, they're simply x value is 3 over 4, and the y value is 3/4 times square root of 3. And so this would be our correct answer for problem number 15. Okay, next on our problem, which is 17, we have -3 and -29 pi over 7. So this is a little bit trickier because we don't have a standard unit point circle measure of angle. We have a standard unit circle measure angle would be over 2, over 3, over 4, over 6. We have this over 7. But the formula is still the same. We have x is equal to r cosine theta, and then we have y is equal to r sine theta. And we're given these angles in radian measure. And so we're going to have to be concerned about, if we use our calculator, which we're going to have to do since we don't have a standard type of fraction in a unit circle, standard unit circle, we're going to have to use this formula purely. So we're going to have x is going to be equal to -3, which is r, times the cosine of, we're going to have -29 pi over 7. But since my calculator is in degrees, I can go change my calculator back to radians and just plug that in. But to convert this to degrees, I'm going to multiply this radian measure by 180 degrees over pi. And then we're going to have pi over pi cancel each other. And so that is going to give us our answer here. So -3 times the cosine of -29 over 7 times 180. So let's go do that. We have -3 times the cosine of -29 over 7 and that's going to be times 180. Make sure our signs are all right. Okay, we have -3. Yeah, everything looks pretty good here. Let's press enter. We get rounded to the nearest hundredth place. Looks like -2.70. So that's going to be, and that's approximate. So let's say approximately -2.70 to the hundredth place. And now for the y coordinate, we have y is going to be equal to -3 sine of, same thing as above, -29 pi over 7 times 180 over pi. So this times 180 over pi, that's a conversion to degrees. And we have, and why do we do that? Because I know my calculator is in degrees mode. And so I'm going to make approximately equal to, go back to the calculator, and we're going to put -3 times cosine of, okay, we have -29, oops, where's that negative sign? -29 over 7 times 180. And so we get the wrong one. Should be, I put the wrong one, didn't I? Let's try negative 3 times sine. I'm going to put cosine there. Control. Okay, negative 29 sevenths times 180. There we go. This is going to be a positive 1.3. So to the nearest hundredth, 1.30 we'll call it. Okay, and so we summarize by saying the rectangular coordinates are, and I'll say approximately equal to, since we're not talking about exact values. We have negative 2.70, comma 1.30, and that's going to be our answer to problem number 17. Okay, next on our problem, same conditions, same directions, except we have this expression here. We have the polar coordinates negative 2 comma pi. And so we're going to have x equals r cosine theta, and then we have y equals r sine theta. Okay, so for this, we could do this mentally. Like we know that we should know that cosine theta is 1. So in this case, we have x equals r, and r is negative 2, times the cosine of pi. Cosine of pi is going to be negative 1. Okay, and if we look at go and look at our unit circle, and we're over here at the left side of the circle at pi, the cosine value, cosine is related to x, is going to be negative 1. So in this case, our value would be 2, our x coordinate. And our y coordinate is going to be y equals negative 2, and the sine of pi is 0. So 0. So our rectangular coordinates are simply going to be the coordinate pair 2, comma 0. And that's it. Next. Let's go to our odd number problem 21. Last one we'll look at in this set. Okay, here we have the polar coordinates 2, comma 270 degrees. Well, again, I'm going to put x equals r cosine theta, and y equals r sine theta. They are the same. But in this case, we're given 270 degrees, which is in degrees and not in radians. Well, 270 degrees, let's kind of take a look at where we are. Here's a circle, and 270 degrees is right down here at the bottom of our 360 degree circle, starting at 0, going around counterclockwise. We have 270 degrees down here at the bottom. And that's going to be translated to 3 pi over 2. Now pi is 2 pi over 2, and down here 270 degrees is, well, 3 pi over 2, okay? And so this is right on the x-axis, and down here, so that the coordinate pair down here would be 0, comma, -1. So the sine value is going to be -1, cosine value 0. So in this case, we have x is equal to r, and the given r we have is 2, and the cosine of at 270 degrees is this x value here, 0. And that is going to be equal to 0. So our x-coordinate is 0, and our y-coordinate is equal to 2. Okay, 2 is our r, times the sine of 270 degrees, or 3 pi over 2, is going to be -1. So what we have is 2 times -1 equals -2. So in this case, we have our rectangular coordinates are just the coordinate pair 0, comma, -2. So here we've done all the odd numbered problems. Good luck with your even numbered problems as a demonstration of your learning, and thanks for viewing.